Hello everyone and welcome to Grand Theft Physics 220, Week 8, Lab 8. So we see Chapter 15 involves using thermodynamics to calculate the work done in specific processes, and the use of this is to determine the change of the internal energy or the heat transfer via the first law of thermodynamics. So what we're going to look here is a specific situation, and then we're going to try to find real-world applications. So, first start with an isothermal expansion from 2 atmospheres, from 1 liter to 4 liters. So one of the things you want to ask yourself at this point is what does the term isothermal mean? Remember, there's been a few different processes we've come across: isothermal, adiabatic, isovolumetric, and isobaric. This is the one, or isothermal, that means there's no change in internal temperature, thus there is no change in internal energy. So we're going to see that the delta U here equals 0, so Q equals W. Now, since there is a change in volume here, there is going to be work done, and remember, work is equal to this. Work is P delta V, or work is the pressure times the change in volume. So in this case, we're going to see this is 2.0 atmospheres, and the change in volume is going to be 4 liters minus 1 liter. Now, there are some conversions you're going to need to do. You're going to need to convert atmospheres to pascals. You're going to have to convert liters to cubic meters, and then get an amount of work done from that. Now, the second part of this says, if this is now adiabatically compressed back to its original volume, what is the change in internal energy here? Also, what are some examples of these processes? Okay, so now you have to realize that in this part, the temperature can change, but there is no heat flow in or out of the gas. Now again, there has to be work that has to be able to be done because the volume is changing, but the actual, like I said, temperature doesn't change there at all. So now our equation becomes delta U equals negative W, since the Q has to be 0 here. So now there's a couple things you can do. Notice it doesn't give you any values that it actually went and anything about the pressure, but you realize it went back to its original volume. So it's a pretty good idea you know what's going to happen with this. Okay, now the last thing is here, what are some examples of these processes? This is where you need to kind of basically go out into the real world and look for examples of an adiabatic process. So what you may want to know is, what is an adiabatic? What is an isothermal? Okay, remember, an adiabatic process is no change in heat. An isothermal is no change in internal energy. So what are some situations that may arise in the real world that you work with that each of these are going to come up with? So that's what you're going to have to look for. Do some web searches, do some searches through literature, the book, or whatnot, and see what an example of this is. Well, that's all we have for this week. Again, if you have any questions at any time, make sure to email your professor, and I hope you had a great class. This should wrap it up for the term, and thank you very much for listening to the lectures.